Okay, so today's problem is about uh, finding the 1 feet contour along this road. So, as we have known, roads usually have a crown. It can be three different types: tangential, parabolic, or reverse. This specific problem has a tangential crown. So, this is important to understand. So, let's start with our steps. So, the step one is gathering the clues. So let's take a look at it. To gather any kind of clues, we'd have to look around and see what's going on. So from the looks of it, it has a 7.5% slope this way. That means from here and onwards, the road is going down. So that's the very first uh, clue that you have. Then we have one point on top of the crown, which is 31.2 feet. So that's the second clue. And then the third clue is the overall length of the road, which is 20 feet. So these are the three things that we have. And also, we know that the road has tangential crown. So these are the four clues overall that we have. So that would be our gathering clues. So with these clues, we'll move on to our second step, which is finding the first elevation. So how do I find the first elevation? We can start from here and we can go down and we can try to find any elevation we like. But I usually do uh, the first elevation that's closest to this value. So if this is 31.25 and going down, the very first elevation that we're gonna have is 31 somewhere here, right? We don't know the total length yet. We will find that out. But the nearest full elevation is gonna be 31. So let's try to find the distance of 31 from 31.25. So our step 2 is going to be finding the first elevation. So the only equation we are going to use for this problem is S equals dE by L, that is slope equals difference in elevation divided by length. And we are going to use that in different direction. So for this, the road is moving downwards in a 7.5% slope. So we know that S equals 7.5%. We know the elevation difference between 31 and 31.25. So dE is 31.25 minus 31, that is 0.25. And we don't know the L and we need to calculate for L. So we know S equals dE by L into 100. Therefore, L equals dE divided by S into 100. So dE is 0.25. S is 7.5, and multiply that with 100. So let's do the calculation. It is 3.33. foot. So from 31.25 to 31, the distance is gonna be 3.33 feet, which is awesome, but we need to put that in scale. So let's draw it in scale first. Again, to draw it in scale, we have to look at the scale. This is 1/16. So that means we need to use the 1/8 and then multiply that with 0.5 or divided by 2. So let's find the 1/8. And let's try to divide 3.33 by 2. This is 1.665 or 1.67. So from here towards this way, 1.6. So this point is gonna be our 31 feet. Okay, so that's our very first step, finding the first elevation. Now we need to do a contour march. That would be the third step. So to do a contour march, we need to understand what's the difference between 1 feet full intervals. Okay, so let's try to calculate for that. So for that, S is gonna be the same because S is uniform all across the road, all through the road, lengthwise. So 7.5%. DE. So we need the next 1 feet. So the next 1 feet is gonna be at 30 feet because we are trying to find 1 foot contour lines. So DE is gonna be 31 minus 30. That is 1 feet. And then we need to calculate the L because we need to find the difference between 31 and 30. So S equals DE divided by L into 100. Therefore, L equals DE divided by S into 100, which makes it 1 divided by 7.5 into 100. Let's calculate for that. $13.33. So from here to 13.33, we will have our next full 1 feet interval elevation point. So let's try to put it in scale. So 13.33 needs to be divided by 2 to get into a 1/16. 6.67, which is awesome. Let's try to find that. So here's our 1, 2, 3, 4, 5, 6, and then a little more. So that would be our 30 feet. Now the question is, do we need to calculate this for all through? No, because we already know the 1 foot length difference. Now we can just use the same distance to go all the way down. So I'll do exactly that. I'll use 6.67 in a 1/8 scale all through. So now for the next step, or step 4, this is gonna be the crown trick. So what would be the crown trick? And why do we need a crown trick? As we know, this has a 6-inch tangential crown. What does that mean? It means if we draw, for example, a cross section between the 31 feet crown contour crown elevation point, the cross section look something like this. This is because the crown is elevated 6 inches over the edges of the road. So if this is 31 feet, these 2 points are gonna be 31 feet minus 6 inches. So we can't have a 6-inch. We need to convert it into feet. So to convert an inch to a feet, we need to divide that value by 12. So 6-inch will become 6 divided by 12 feet. So that is 0.5 feet. So this value would be 31 minus 0.5, which is 30.5 feet. So the section would be something like this: 30.5 and 30.5. So if you have a crown of 31 feet and cut a cross section across the road, that value of the edges would be 30.5. So let's draw that. I'm not drawing it for both sides. I'll calculate only for one side. So this point is gonna be 30.5. Now the road is going down this way. So if this is 30.5, a 31 would be somewhere here, upwards, because the road is going down this way. So again, we need to find the 31 from 30.5, and we don't know the length of this, length of the edge. So let's calculate for that, and we will use the same formula. We have the S, that is 7.5. In this case, the DE is gonna be 0.5, because we are differentiating between this and this. So I'll write that down: 31 minus 30.5, 0.5 feet. So S equals DE by L into 100%. Therefore, L equals DE divided by S into 100%. This becomes 7.5. This becomes, sorry, my bad. DE becomes 0.5. S becomes 7.5 into 100. So let's find that out. 7.5 into 100. So 6.67. This way. So let's find that out. And we can't use a 6.67. We need to divide it by 2 to put it in scale. 3.33. And we're dividing because we don't have a 1/16. We only have a 1/8 scale. So yeah, 3.33. and we can't exactly find a 3.33 with this scale because it doesn't show us decimal points, but we'll do an approximation for this. So 1, 2, 3, and somewhere near that 3 would be 3.33. Again, 1, 2, 3, and just a little more. So that would be our 31 feet. And we can draw the same for the other side of the road. And then try to find a 3.33 from that intersection. 1, 2, 3, and a little more. So 3.33, or we could draw a perpendicular line from here. So that would be our 31 feet in these two edges. Okay, so let's erase the perpendicular line because we don't want to create any confusion. And let's just connect this with the dots. So this V-shaped line is gonna be our 31 feet contour line. Now for step 5, that would be the contour march part 2, contour march along the edges. And this is easy work for us because we already know we need to do 13.33 between these two. All right, so let's try to do that. And we know already that this is 6.67. I'll do exactly that. I'll create 6.67. I'll create more points with 6.67 difference. So I'll speed this part up. So with that, we are done with the part 2 of the contour march on the edge of the road. So all that is left for now is to connect the contour lines with the dots. So that should be super easy. We just connect the corresponding elevation points with one another with sharp straight lines, because this is a tangential crown, so it needs to happen like this. That would be the 1 feet contour lines for this specific road. So that's how you solve this problem. Those are the 6 steps. Again, we gathered the clues within the picture and the question. Then we found the first elevation point, that is 31 feet from me. You can go for 30 or anything, but 31 would be the logical choice here. Then we did a contour march on the crown. Then for the crown trick, we calculated this elevation point right here. And then from here, we found out the 31 feet towards that way, because this way it's going down, that way it's going up. And then we did 2 more contour marches along the length of the road. And then essentially in the end, we connected all the dots. So those are the 6 steps of finding the contour lines with a crowned road.